Hello everyone, welcome back to the channel. Imagine asking an AI to plan your entire vacation, flights, hotels, activities and so on, and watching it coordinate multiple different APIs seamlessly. And today I'm showing you how Model Context Protocol transform complex travel planning from developer nightmare into pure magic. And if you are building the future of AI agents, smash the subscribe button. We're diving into the protocol that's making traditional HTTP integrations look really prehistoric. Let's dive in. So, what is Model Context Protocol, or MCP? Imagine you have a powerful smartphone, but it can only work in isolation. No internet, no apps, no access to your photos, contacts, or any other data. That's essentially how AI models like ChatGPT, Claude, and others have been working until now. The Model Context Protocol, or MCP, is an open standard developed by Anthropic that enables developers to build secure two-way connections between their data sources and AI-powered tools, much like how USB-C provides a standardized way to connect devices to various peripherals and accessories. So what does MCP solve? What problem does it solve? So you can imagine there's a problem that is called n times m problem. Before MCP, connecting AI to real-world data was like having a Tower of Babel situation. You can imagine you have a world without standards. You have 5 different AI assistants, for example, Claude, ChatGPT, Gemini, etc. And you want them to have access to 10 different tools, such as Google Drive, Slack, GitHub, your company databases, and so on. And without a standard, you would need 5 times 10 equals 50, right? Different custom connections, because these connections are made via API calls. This created what technologists call the n times m problem. Every AI system needed its own custom connector for every tool, leading to duplicated effort across teams, inconsistent implementations, security vulnerabilities, and maintenance nightmares. I have 2 agents that are doing the same thing, planning my travels. The agent on the left, or the workflow on the left-hand side, doesn't use MCP. Instead, I use API calls, and the agent has access to several HTTP request tools that make API calls to several servers, including Tabuli Search, SERP API, and so on. But on the right hand side, I have also a travel agent. But in this case, the agent doesn't connect to any HTTP request tools. Instead, it is connected to 4 different MCP tools. So, as you can see, with these MCP tools, I don't need to specify any parameters as I did with the agent on the left hand side, where I had to specify the body parameters to be sent with each API call. And I had to do it manually by checking the documentation of the API. But on the right hand side, I didn't have to specify any body parameters, because this is a standard that the agent knows that there are certain parameters that it needs to specify before making the execution. So what is the difference between MCP and HTTP requests? Before diving into how MCP works, and it's important to understand how it differs from regular web requests, or HTTP, that most people have heard about. With HTTP requests, the traditional way of connecting to an API, that is a one-time conversation. For example, you call a restaurant, you place an order, you hang up. It has no memory. Each call is independent, and the restaurant doesn't remember your previous orders. HTTP request has no relationship, which means after the call ends, there's no ongoing connection. When an API call is successful, then the connection is closed. So there's no ongoing connection. The technical characteristics of HTTP request is, first of all, it's stateless, which means each request is independent with no memory of previous interactions. It is two-way initiation, which means the client always starts the conversation. It has generic format, which means it is designed for any type of web communication. And it has manual integration, which means developers must build a custom code for each API. This is exactly the case what I did here. And the problem is, when the API changes, for example, the body parameters changes, then I have to manually go to the documentation of Serve API or Tavily API in order to check for the updates, and then I need to go back to my agent, update all of these parameters accordingly. So it's all manual work. So how about MCP, which is the AI optimized way? You can think of MCP like having a personal assistant with ongoing relationships. It has persistent sessions, which means your assistant maintains ongoing conversations with various services. And it's context awareness, which means it remembers previous interactions and maintains state. It has standardized communication, which means it speaks the same language with all the connected services. It has intelligence discovery, which means it automatically learns what each service can do without you specifying what service it has access to. This is called tool discovery. And with regards to technical characteristics of MCP, first of all, it is stateful, which means it maintains the context and session information across interactions. It is bidirectional because both client and server can initiate communication. It is in AI-specific formats because it's designed specifically for LLM consumption, for example, tools, resources, and prompts. With MCP, your AI agent can have the ability to discover tools, which means the servers automatically advertise their capabilities to the AI agent, and the AI agent, based on the information it's provided, can discover the appropriate tools to use when executing your request. I've put a comparison between MCP and HTTP request just in case you're curious here in this diagram. As you can see, with the HTTP request, there's no ongoing relationship, which means when the API call is successful, then the connection is closed and it is stateless, which means no memory between requests. Whereas with MCP connection, it is stateful because the agent can remember the context and allow bidirectional communication between the client and the server. So why does MCP matter for AI? Well, HTTP request is like having amnesia, which means each interaction starts fresh with no context or memory. An MCP is like having a persistent, intelligent assistant that remembers conversations, understands context, and can have meaningful ongoing relationships with your tools and your data. So this difference is very important because the AI needs the context to provide intelligent responses, and it needs to perform complex tasks which often require multiple related interactions. And it's also about user experience because it offers much better user experience when the AI remembers what you're working on. You don't want to message an AI and it forgets what you've talked to it previously, right? And finally, it's about security because MCP provides a standard way of security that can be more sophisticated with persistent authenticated sessions. And finally, it's about security because it can be more sophisticated with persistent and authenticated sessions. Now we have differentiate between HTTP request and MCP. Let's dive deeper into how the MCP works and what is the architecture behind it. There are three main components in an MCP architecture. First, that is the MCP client, the red box. So this is the communication manager. And you have the MCP servers, which is the green box. And we have the host application, which is the blue box. So how does this work altogether? So first of all, you interact with your host application, which can be the application that you use to interact with an AI application. So in this case, it can be a Claude desktop, ChatGPT, or etc. Then the information is delivered from the host application to the MCP client. In this case, this AI agent. So The AI agent maintains the individual connections with the server, which is the MCP server right here. And the MCP server is connected to the data source. So if you develop your own MCP servers, then they are connected to your data sources. But if you use a third-party MCP server, then it is connected to the data sources of the developers or the managers of the server. Let's have a look at this step-by-step MCP request, see how it works. First of all, the user makes a request. For example, help me prepare for Monday's meeting. Then the request is sent to the client, which means the AI agent in this case will ask the MCP server, what can you access? Which means this is called the tool discovery. And then from the MCP server, it can either connect to the data sources or the schemas in order to collect information about tools such as Slack, Google Drive, Calendar, what execution is available. Then the AI agent will perform the analysis or processes on all the data together with the full context, because it takes into account the user's request, the data sources from the MCP server, and then processes all data all together with the full context. Then once it has a full picture of what has to be done and it has done the job, then it responds with a summary or actionable insights to the user. So that's how MCP works. Now we understand what MCP is and how it is different from traditional HTTP request. Let's dive deeper into how it performs in real cases. Let's have a look at these two workflows. On the left hand side, I have the travel agent workflow that doesn't use MCP. And on the right hand side, I have the travel agent that uses MCP. And you can tell they are very different, because on the left hand side, it has to have access to several HTTP request tools, and the workflow is quite long and complex. Whereas on the right hand side, I have the travel agent that has access to MCP tools, and the workflow is much cleaner. If you haven't watched my previous video about travel agent with the workflow on the left hand side, then please have a look at the video in the description. Now let's see in action how this works. Here's the request that I'm going to use. Plan my travel to Paris from Bristol in the next 3 days. I'll stay for 3 nights close to Eiffel Tower, and 2 people will travel. What I expect is the agent will execute these Tableau tools and Airbnb tools. So what are these? These are the MCP tool that is connected to the MCP server of Tableau. And this will basically list all the tools available from the Tableau server so that the agent knows which execution is the most appropriate for it to perform the execution. And the prompts that I use is I ask the agent to always use this tool first in order to browse and identify the specific Tableau tool configuration that best matches your search requirements before proceeding with executing it. So by doing this, the agent will always fetch the information from the Tableau tools to see what actions or what executions are available before it proceeds to the next tool, which is Tableau execution. So Tableau is a search engine that I mentioned in my previous video about travel agent. If you haven't watched the video, please see the link in the description. The Tableau execution tool is basically allowing the agent to execute the appropriate tool after browsing the available executions. With this tool, for example, the agent knows that there is an action for searching ABC. Then it will perform the search on the query that it comes up with using the appropriate tool. As you can see, I have specified the tool name here, and the tool name comes from the browsing of the Tableau execution tool. I will send the request, and what I expect is the agent will first query either of these tools, Tableau tools or Airbnb tools, in order to find out what executions are available from the MCP servers. Then it will call the Tableau execution and the Airbnb execution tools with the appropriate tool name. So now I will send the request and see if the agent can perform what I expected. Great, so the execution has been done, and as you can see, first of all we have the tablet tools that was executed, and we have the tablet execution that was executed, but we didn't see the Airbnb tools got executed. We examine why that is. So I will go to my travel agent and I'll go to the logs. So in here I can see the agent has called to tablet tools, and what is the output of this tool? So it outputs the schema together with the tool name. As you can see, tablet search is the tool name, and it has a description, it has a schema including the parameters that the agent can use for performing the search using tablet tool search, right? Then once it has information about all the tools available, then you can see it calls the tablet execution tool. So in here, what does it do? First of all, it uses the tool name, which is tablet search, with the tool parameters, and these are the parameters the agent came up with. It has the query, it has the search depth, it has the topic, it had the max results, and this is the output of the tool with the query that the agent came up with. Great, so we understand that the agent uses tablet tools in order to understand what executions are available, and then it uses the tablet execution correctly. Now let's have a look at the email that I received in order to see if I had the information I wanted. Here is the email I received from the agent. As you can see, I have the flight information including 3 flights from EasyJet, KLM and British Airways, which is good. I can click on this button in order to book my flight, which is great, and the duration is 3 nights, correct. Estimated budget £1,000 in total, because I didn't mention my budget in my request, so the agent estimated the budget, which is great. And here it came up with some daily activities, including the links to book the activities, which is very great, and accommodations. As you can see, it found the hotels instead of Airbnb because I didn't specify what type of accommodations I want to stay, so it assumes that I will be staying in a hotel, which is great. And it has the budget breakdown, it has the planner's recommendations, which is absolutely great. So now I want my agent to use the Airbnb tools. I will use the same request, but this time I will add this sentence: I prefer staying in Airbnb. So my expectation is, first of all, the agent will call this Airbnb tools in order to understand what executions are available in the Airbnb MCP server, and then it will execute the Airbnb execution tool with the correct tool name. I will send this request now. Great, now the execution has been completed. As we see, the agent has executed all these 4 MCP tools, which is great. And if I have a look into the travel agent and I go to logs, as you can see, first of all, the agent will use the travel code tool in order to calculate the time, which is great because I made it very clear in the prompt that the agent will need to use the code tool in order to calculate the time, so that it doesn't assume anything in terms of time. Because as you know, large language model is not very good with time, so it has to use the code tool in order to be very accurate, which is great. Now, as we saw previously, the agent used the tablet tools in order to find out what actions are available and the schemas and the parameters available in each tool of the tablet MCP server. And we can see the output includes all of the available tools, including tablet crawl, tablet search. Then the agent uses the Airbnb tools, as you can see here, we have multiple tools available in the MCP server of Airbnb. First of all, we have the Airbnb search and with the schema of different types of parameters here. And then we have Airbnb listing details and so on. And after understanding the available tools, you see what the agent did next? It executed the Airbnb execution tool. And what parameters did it use? First of all, it configured the tool name to be Airbnb search. And these are the parameters. The parameters fall into the schema defined by the MCP server. As you can see here with the Airbnb search, this is the schema. These are the parameters that the agents can use. So we don't have to configure all of these parameters ourselves. Instead, the agents will have a look into the schema of the execution of the MCP server in order to find out which parameters are suitable for it to use. And it did. So the agent used these parameters: location, check-in, check-out, adults, which is great. And this is the output from the MCP server of Airbnb with the corresponding search, right? And then you can see the agent did another search with Tabuli execution. And what did it do? It used the Tabuli search tool in order to search for flights from Bristol to Paris on the days of 25th of August, and then staying for 3 nights, which means I will be returning on the 28th of August. This is absolutely great. And these are the details of the flights. And after gathering all the information, the agent output an HTML format. This HTML is then used to send an email to me. And this is the email that I received. As you can see, I received information about the flight options, similar to the previous email, which is great. And then I received the daily activities for 4 days, which is good. But this time, the accommodation is different because the agent is now showing me Airbnb accommodations instead of hotel accommodations. Similar to the previous email, I also had a budget breakdown and the planner's recommendations. All great. So, in overall, MCP, how does it work and what can it help? As you can see from these two workflows, MCP really helps you simplify the implementation of your AI agent because you don't have to create multiple HTTP request tools and you don't have to configure the API endpoints like with this one and configure all of the body parameters or query parameters manually, like with this one or this one. You can see in here, I have to configure all of these parameters manually. So you can imagine if you have multiple workflows using multiple HTTP request tools, but when one of these API changes, which means they add new parameters or change the name of the parameters or change the uses of parameters, then you have to go back to your workflows and update all of those parameters manually, which is not ideal. Whereas with MCP, when you have access to the available tools available on the MCP server, for example with the Airbnb tools here, you can see we have access to the tool name and we have all the schema here. So all the schemas, the parameters here, if the developers of the server update their parameters or update the usage of their parameters, then all of these properties will be updated and our agent will have access to the newest information rather than we have to change or update the information manually. So that is very beneficial and also time saving for implementing AI agent. So I hope you have understood what MCP is and the benefits of MCP. So in the next video, I will show you step by step of how to implement the MCP, including installing the community node for MCP in n8n and how to make the MCP tools work with your agent. If you think the video is helpful, please give me a like and also consider subscribing to the channel. Thank you very much. See you next time. Bye.